Hello YouTube. So in this video, I wanted to cover a machine learning project that I did for human activity recognition. So the data set is people wore a watch and that watch recorded the acceleration and the X, Y, and Z axis in the three dimensions in our normal world, not in the machine learning world with 55,000 dimensions. And from this data, we had to learn to recognize what activity the person is doing. So whether the person is standing, sitting, going upstairs, climbing upstairs, going downstairs, running, jogging. I don't know what the exact labels were, but it was something like that. So first, I'm going to explain the data set, and then I'm going to explain the code, which I coded up in Keras, which is a deep learning API/library, in which it is really simple to make deep learning models. And by no means am I a machine learning expert. I'm just a 17-year-old who is really interested in deep learning, and I've learned some stuff on the internet, and I wanted to share it with you guys because I think Keras is such a great library. We can make like deep learning, like state-of-the-art deep learning models in just a few lines of code, and it really isn't that hard when you understand the basics.
Okay, so firstly, we're gonna just explore the dataset real quick. There is like three columns which we don't care about, and there's X, Y, and Z axis acceleration, which we do care about. We're gonna take this and we're gonna take it as a time series data, and we're gonna take 60 time steps and then 60, and then try to predict what the person is doing at the current moment. So this is time series data, and that's we do classification with time series data with recurrent neural networks. So I'm going to just assume that you guys are coders and know a little bit about machine learning. If you don't, I can make like a whole beginner tutorial for Keras and for machine learning if you don't understand anything that I will be saying right now. So I will go over this pretty quickly. We're just importing the datasets, of course, or not the datasets, the libraries and modules, and we're importing the dataset, dropping any NaN values. We're going to locate the third to the sixth column, which are X, Y, and Z axis accelerations, and we'll also locate the values of the classification, so of the classes, right? Standing, sitting, and similar. Because we also have not just standing, but we also have like biking and stairs down and similar actions which people performed and the watch recorded. We're just going to import the minimax scaler and scale the data set with fit transform. Also going to import or make like a label encoder, which we are going to use. We don't need this actually. We're going to use it to fit it to our training labels and then transform the training labels into numbers. So 1, 2, 3, 4, 5, 6. I think there are 6 classes. And then we still can't use that. We have to convert it to dummy Y variables. So like there's 6 columns with zeros and ones specifying which class it is. Now in this code, we are going to specify, we're going to open up 3 lists. Also going to specify what are our labels for training, and then we are going to make the time series data by going from 60 to 400,000. Actually, when I trained, I went to 100,000, but later more on that. So I did that so we could create time series data by taking 60 time steps into account, and then a classification, a label which we had to predict. So we're just appending to the list I minus 60 to I, so the time series data, and then just one step further, we go each step in the for loop. And then we just convert to Numpy arrays and reshape them so that they have 3 dimensions, not only 2. We do that because we need to stack them up in the third dimension. Because the recurrent neural network will take in 3 dimensions because we have 3 columns. Not 3 dimensions, but it has to take in, 3 rows of the third dimension because we have 3 columns of which we are taking input data. Then we're just going to import the Keras model, initialize the model, and we're going to add 3 LSTM layers, each with their respective dropout of 20%, so we can just reduce overfitting. Maybe not even needed because there is a lot of data, but still regularization is always a good idea. We're just going to finish it up with a dense layer of 6 units and a softmax activation. Because this is a categorical cross entropy problem, we have to classify. This is a multi-class classification. I'm going to use the Atom optimizer. It's pretty good, works for almost every problem perfectly. The loss is categorical cross entropy, of course, and we're just going to monitor the accuracy. We're going to fit the model through, I fitted it to 25 epochs. It may not even be necessary. After, I think, 5 epochs on training on the first 100,000 examples, I got an accuracy of about 85% on the training set, and about 65, I think, on the test set. And you're thinking, wow, that's not pretty good. But actually, it sort of is, because this data is not actually perfect. I suppose that maybe it's not just continuous, because there is a lot of data. So they may be just like stacked one like activities on activities, which is, it's not like a perfect time series data. And this problem is pretty difficult for a recurrent neural network, because we have such a complicated task, taking into account 60 time steps and 3 columns, and we have six classes, and we only have the acceleration, which does range and change, but it is pretty hard to predict. So 65% on the test set is for I am actually pretty. I find it to be pretty good, because, for example, my iPhone doesn't even recognize when I'm riding my bike. It just says that I'm walking if I'm riding it sort of a normal speed, and like counts it as steps. So I have, at the end of the day, I have like 15,000 steps, while I actually did maybe 5,000. So we're just going to do the same thing that we did with the time series data for the test data. Also with the labels, we're just going to test it from 400,000 to 500,000. Again, converting to Numpy arrays, make it into 3 dimensions, stack them up in rows in the 3rd dimension, and evaluate it on the test data. Now, I trained it on the first 100,000 examples, training to about through around 10 epochs, and I got, as I said, 85% accuracy on the training set and 65 on the test set, which is again pretty good, because we have 6 classes. So it is not like a binary classification where the beginning like random accuracy would be 50%. The random accuracy is 100 divided by 6, so a lot less. So this is actually an okay accuracy, if you ask me. So you can train it maybe through more epochs. You can make a bigger network, maybe add more regularization to not overfit to the training set. And one thing that we should surely do is, which should surely help, is training it from 100 to 400, like I did here. So 100,000, or right, yeah, from 60 to 400,000, rather than from when I trained it up to the 100,000 example. Now that is going to take a little bit, like a few more epochs, right? So I set it to 425. I think that's a pretty good number. It would probably learn, and then we could test it from 400 to 500,000, because that's right around how much data, how much rows we have. So thank you for watching. If you enjoy deep learning and you're passionate about it just like me, consider subscribing, and I'll see you in my next project, in my next video. And so that's my project. I think it's pretty interesting with the X, Y, and Z axis and classification of 6 labels, 6 activities. If you enjoyed it, if you're passionate about deep learning just like me, consider subscribing and dropping a like, and I'll see you guys in the next video.